All right, now we're going to talk about the quotient rule for radicals. And this states that the square root of a quotient equals the quotient of the square roots of the numerator and the denominator. So let's try and do some examples of those. So what does that mean exactly? Well, my first example, I have the square root of 6 over 2. Well, it means that I can find the square root of 6 over the square root of 2. Let's see, using the product rule, the square root of 6 is the same thing as the square root of 2 over the square root of 3. And then I'm going to put it all over the square root of 2, and look what happens here. These cancel out. So it equals the square root of 3. Now, if you didn't see that, let's just look at this fraction again. The square root of 6 over 2. Well, 6 over 2 reduces, right? This reduces. 6 divided by 2 is 3. So you can simplify your radicals, like when they're written in a fraction like this, you can simplify before you start taking the square roots. All right, so let's do another example. I have the square root of 14 over 8. The square root of 14 over 8. So I can rewrite that as the square root of 14 over the square root of 8. Well, let's see. The square root of 14 is the same thing as the square root of 2 times the square root of 7. The square root of 8 is the same thing as the square root of 2 times the square root of 4. The 2's cancel out, right? Square root of 2 over the square root of 2, those cancel out. That equals the square root of 7 over the square root of 4. But the square root of 4 can be simplified into 2. So I have the square root of 7 over 2. Now I'm going to use the same idea that we used up here. I'm going to simplify this first. So I'm going to reduce. I'm going to divide everything by 2. That becomes the square root of, when I divide by 2, that becomes the square root of 7 over 4. And then I'm going to rewrite it as the square root of 7 over the square root of 4, which equals the square root of 7 over, what is the square root of 4? It's 2. So again, it doesn't matter what method you like best, both of them will work for you. Our last example here is the square root of 72 over 32. So I'm just going to go ahead and divide by 2 on this before we start breaking it up. So when I divide this radical, numerator and denominator, by 2, I end up with the square root of 36 over the square root of 16. Well, let's see. I'm going to rewrite it as the square root of 36 divided by the square root of 16. And I know that the square root of 36, well, that's the same thing as 6 squared. The square root of 16, let's see, that's the same thing as 4 squared. And that equals 6 over 4. Oh my goodness, but what can I do here? 6 over 4 reduces to 3 over 2. So let's go back to this. What else could I have taken out of here? Maybe these are both divisible by 8. And I didn't see that at the very beginning, so I actually could have divided by an 8. But either way, as long as we reduce at the very end, you'll get the same answer, okay? So that's using the quotient rule. And then sometimes you're going to be asked to use both. So let's look at that. We're just going to do 2 of these. So using both. So let's first go ahead and use the product rule. And I'm going to rewrite this as the square root of 15 times 8, because we multiply fractions straight across, right? Over the square root of 2 times 5. So 15 times 8 is 120. So I have the square root of 120 over 2 times 5 is 10 over the square root of 10. So now let's break it up if we can. The square root of 120 is the same thing as the square root of 12 times the square root of 10 over the square root of 10. And what happens here? My final answer is the square root of 12. Okay? What's inside of that? Well, the square root of 12 is the same thing as the square root of 4 times the square root of 3. So that actually equals 2 root 3. Final answer. Okay? Let's look at another example. I have, again, I'm going to multiply straight across. I'm going to
write this out so you can see it. 3x to the 4th times 6x to the 5th over x squared times 4x. So I'm going to multiply my constants first. 3 times 6 is 18. X to the 4th times x to the 6th. This is where my exponent rules come into play. When the base is the same and I multiply, I do what with the powers? I add them. Over 4 times x to the 3rd. So this is all underneath radicals. So let's get over here. So let's see. 18 is the same thing as the square root of 9 times the square root of 2. X to the 9th power, well, let's see. That is the same thing as x to the 8th times x, right? Because when I add the exponents, I get that power of 9. The square root of 4 times x squared times the square root of x, right? So look what happens. These x's cancel out. The square root of 9 is 3. The square root of x to the 8th power is actually x to the 4th. And I have a square root of 2. So taking care of everything in the numerator. The square root of 4 is 2, and the square root of x squared is x. Now let's use some division rules again. X to the 4th over x. This cancels out, and this becomes a 3. So my final answer is 3x to the 3rd root 2 all over 2. I'm going to show you a different way to think about this, starting with the product right here, the simplified product. You can also think of this as the square root of 18 times x times x times x times x times x. I'm going to do that 9 times. And then this is all over the square root of 4 x times x times x. And do you remember doing this when we first learned about exponents? We just canceled them out. So that becomes the square root of 9 times the square root of 2. And I have 1, 2, 3, 4, 5, 6, which is going to end up reducing to a 3 all over the square root of 4. The square root of 9 is 3. The square root of x to the 6th power is x cubed. The square root of 4 is 2. So I've taken care of this, this, and this. All 3 of these are perfect squares. This is not. So I have to leave it under a radical. All right. I want you to go ahead and pause your video, and you go ahead and do this one. Pause the video and do this one, and I am going to pause the video also and do it very quickly and just show you the. All right, so here's the final answer when I have the square root of 8y cubed divided by x to the 5th times the square root of 6x divided by 9y squared. My final answer is 4 times the square root of 3y all over 3x squared. So go ahead and take a look at that. Freeze it. So the last part of our notes is about rationalizing the denominator. And so what that means is that we can never, ever leave a radical in the denominator. It's illegal. It's not allowed. So when we have a radical left in the denominator, we have to get rid of it. And we do that by rationalizing the denominator. The definition says that when a radical is in the denominator of a fraction, you can multiply the fraction by an appropriate form of 1. Well, what does that exactly mean? So let's take a look at it. Our first example, I have the square root of 25 over 2. So I'm going to rewrite this as the square root of 25 over the square root of 2, and I know that 25 is a perfect square. That equals 5 over the square root of 2. I have a radical in the denominator. I cannot leave it there. I have to rationalize. And we do that by multiplying by that radical value, which is the square root of 2. Now notice, I'm going to multiply 5 over the square root of 2 times the square root of 2 over the square root of 2, which is just a fancy way of writing the number 1. And then I'm going to multiply straight across. 5 times the square root of 2 is just that, 5 root 2. The square root of 2 times the square root of 2 is the same thing as the square root of 4, which is 2. So my final answer is 5 root 2 over 2. So this is good. This is rationalizing the denominator. This is bad. I cannot leave it like that. You cannot leave a radical in the denominator. Good, rationalize, bad, have a radical in the denominator. Let's try it again. So we're going to multiply straight across first. So 5 times 3 is 15 x to the 4th all over the square root of 6 times x to the 5th. All right, so now I'm going to start breaking this up. So that's the same thing as the square root of 5 times the square root of 3. That takes care of the 15. And x to the 4th, the square root of that is just, in fact, x squared. I'm not putting that under a radical. I'm simplifying it right now. All over the square root of 2 times the square root of 3. And then x to the 5th is the same thing as the square root of x to the 4th times the square root of x. So let's look at what we can do here. Well, x to the 4th power underneath the radical is the same thing as x squared. Okay? The square root of 3 over the square root of 3 cancels out. So in the numerator, I have the square root of 5 times x squared. In the denominator, I have the square root of 2 times x squared, but I also have times the square root of x. What happens to these right here? They cancel out. So again, square root of 5 over the square root of 2x. Can I leave this as my answer? Is it simplified? No, because I have a radical in the denominator. So I have to rationalize. And I'm going to rationalize by multiplying by that creative 1, or that appropriate 1. So I have to multiply both the numerator and the denominator by the square root of 2x. So let's keep going. So 5 times 2x is 10x. 2x times 2x is 4x squared. And that's all under a radical. So I have in the numerator the square root of 10x. But remember that the square root of a number times the square root of that same number is just, in fact, that number. So here is your final answer. And that makes sense because the square root of 4 is 2, and the square root of x squared is x. All right, here's our last example. It's very basic. 21 over the square root of 3x. So I don't have anything that I need to do to simplify this, but I cannot leave this radical in the denominator. So I'm going to multiply both the numerator and the denominator by the square root of 3 over x. So this becomes 21 times the square root of 3x over the square root of 3x times the square root of 3x is, in fact, just 3x. However, you'll see in this example, I can reduce the 21 and the 3. 3 will go into 21 7 times, so I have 7 times the square root of 3x all over x. Now this is an excellent answer. So your homework today is a worksheet. The sub should have given you the worksheet when she passed out your notes, but if not, make sure you grab that from her, and it's posted in the module. Good luck.